Welcome back. Now we have an animation blueprint, and we're updating the variables here in the event graph. Now this animation blueprint has a C++ parent class, as all blueprints do, and we can see that up here at the top right. It says parent class Anim Instance. That's the C++ class. Now in C++, it's Anim Instance, and we can create a C++ class to use. Now we can always see and change the parent class to a blueprint in the class settings. Now I have my screen resolution set to a large size so you can see this better on the video, but you should see class settings up here at the top. I have to expand the toolbar to show it right here, but you should see the icon up there if you have your display settings set to normal. Now if I click class settings, now in the details panel, I see some settings for the class, including the parent class. And there's a drop-down, and I can choose different classes to be the parent for this animation blueprint. Well, we are going to create a C++ class to be the parent for this animation blueprint, which means we need a new C++ class. So let's go to the content drawer into C++ classes /public characters. And we'll make one right here in the characters folder right next to /character. So let's do it. We'll right-click, create new C++ class, and we'll select all classes so we can search for the class we want, and that's Anim Instance. So Anim Instance is the C++ class that animation blueprints are based on. We're going to create our own. So let's select that, click Next, and we can give it a name, and I'm going to call this /Anim Instance. And I can let it go straight into the characters folder right next to my character. So let's click Create Class. So we can click Reload All. Now I'm going to go ahead and close the live coding window, and here's our C++ class. Now the body is pretty empty, but we're going to add a couple of functions. Remember, in the animation blueprint in the event graph, we have event blueprint initialize animation and event blueprint update animation. And as I mentioned, these are a lot like tick and begin play. They're sort of different because the animation blueprint is actually sort of ticking all the time. You can see this sort of orange pulsing going on here, which indicates that this is actually evaluating right now. That's why we could change values and see that change reflected in the viewport here. For example, if I select ground speed, and here in Event Blueprint Update Animation, I set the ground speed to a non-zero value, such as, say, 400, and compile, you'll see that that change is taking place, and we can see that happening here in the viewport. So the animation blueprint is updating all the time, even when the game isn't even running. So for that reason, we kind of have to be careful, because as soon as we make our C++ class a parent to this, we now have this C++ class, and our C++ class will be updating as well, even if the game isn't playing. So if we're trying to access null pointers or anything bad like that, we can crash the editor very easily. So this can be sensitive, and usually I like to close the editor when compiling any changes to the Anim instance for that reason. You can really easily crash the editor because compiling sort of restarts everything, and values that were set before are now no longer set, and you might be attempting to access null pointers. So we're going to be closing the editor before we compile any changes to the Anim instance. Now, before we start programming the Anim instance, we're going to take our character and our character movement component and delete those variables because I want to create those variables in C++ instead. So we're going to take all these nodes here and hit delete, and take our movement component here and delete that as well. And we're also going to delete character and movement component from right here in my blueprint. So we'll delete character, we'll delete movement component, and now we don't have those variables here. We're going to go ahead and compile that. And we'll get an error now. We can't actually compile because the velocity here, which is accessed from the movement component, well, it doesn't have a valid movement component anymore. But that's okay. We'll make one from C++ instead. Now, look at these two events. Initialize animation happens at the very beginning. We even know that it's before the game starts. It's really as soon as we compile. And event blueprint update animation is updating constantly, right? Every frame, even when the game isn't running. And these have corresponding C++ functions as well. So we're going to use those here in our Anim instance. We're going to first make a public section. And we're going to override a couple of virtual functions. Now, the first one is going to be the analog to our event blueprint initialize animation. In C++, its name is a little different. It's a virtual function, it's a void function, and it's called native initialize animation. And it's an override, so we're overriding this as it's been inherited from the Anim Instance class. Now, we can go ahead and create this function definition, and now we have it defined here in /animinstance.cpp. And because this is an override, we're going to call the super version. So we'll call super native initialize animation. So we're calling the parent version there, just to make sure anything that happens in the parent version in Anim instance, that will be executed here, as it's most likely needed. Now, we also have the C++ version of the other event, which is called blueprint update animation. So this will also be a virtual override. So we'll say virtual void, and this function in C++ is called native update animation. And just like the tick function, it takes a float, and we're going to call this delta time. And this is an override. So let's go ahead and define this one. And because this is an override of a parent function, we're also going to call super on this one. So super native update animation. And we're going to pass delta time straight through to that parent version. And now we have the C++ versions of those two events. And native initialize animation is where we can initialize our variables. And we're going to create some variables. So here in /anim instance, let's go ahead and do this. And I'm going to keep these variables public on the Anim instance. You can make them private, but I plan on exposing them to blueprints, and I don't see an immediate need to make them private. So I'm going to make them public. And the first one I'm going to make is an a/character pointer called /character. And I'm going to forward declare a/character. Remember, we can forward declare on the same line like this. In our other classes, we forward declared up there, but I'm going to forward declare down here this time, just to show it both ways. Now, I plan on accessing this from within our animation blueprint, and to expose it to blueprints, it needs a uProperty. Now, we've been using visible anywhere quite a lot, and that makes our variables visible in the details panel, but I want to access this in the event graph. And to expose it to the event graph, I need blueprint read only, or blueprint read write, either one. Blueprint read write would let me set this and change it from the event graph, but I don't need to do that. I just need to access its value. So I'm giving it blueprint read only. And we also know that we want that character movement component. So I'm going to forward declare a uCharacter movement component. And this is going to be a pointer called /character movement. We'll call it that and make this blueprint read only as well, so we can access it from the animation blueprint event graph. And we also know that we want a float called ground speed. So I'll make that, and this will also be blueprint read only. And we can give these categories while we're at it. I'm going to put ground speed in the category movement. And /character movement can also go into the category movement. And I'm going to leave /character without a category. Okay. Now, I'd like to initialize these. And what we did in blueprints was we used try get pawn owner. That's a function in C++ as well. So here in native initialize animation, which gets called quite early on, we're going to call try get pawn owner and cast it to an a/character. Now, if we're going to use a/character, we need to include /character.h. So I'm going to include that here. And /character exists in characters. So we need to include that characters folder. So we're going to say characters/character.h. And now we can call try get pawn owner. Now try get pawn owner returns a pawn. If we hover over it, we can see its return type, pawn star. Visual Studio likes to put the star spaced apart from the type, but this is type a pawn star, pointer to pawn. So don't mistake that. Now we're going to take this and we're going to cast it just like we did in Blueprints. So here's how we use cast in C++ for Unreal Engine. You see, Unreal Engine has its own cast function. If you come from regular C++, you're probably familiar with static cast, which requires the type you're casting to and the value that you're casting. Static cast is good for types that you know at compile time. You have to know those types at compile time. If you wanted to cast a polymorphic type, like a child to a parent type, you'd have to use dynamic cast. Dynamic cast requires the type you're casting to and what you're casting. Now, these are great for regular C++, but in Unreal Engine, we use the cast function with a capital C, and it works the same way. We put the type in the angle brackets here, so I want to cast to a/character. And we put the value we're casting in the parentheses, and I want to cast the result from try get pawn owner, this pawn value. So I'm going to click and drag it straight into the parentheses there. And now this cast is going to take this value returned from try get pawn owner, which is an a pawn, and cast it, or at least attempt to cast it, to an a/character. So if whatever's in the parentheses is not pointing to an object of this type in the angle brackets, the cast will fail and return null. Also, if the thing we're passing into the parentheses is null, the cast will fail and return null. So that's how casts work. And we're going to use this to initialize our /character variable. So we're going to take /character and use the assignment operator and assign it the value returned from cast. Now, this could fail, which means if we're going to access the /character and try to use it, we need to check to make sure it's not a null pointer. So we're going to say if /character. And if it's not a null pointer, then we can access member functions on it, such as, what do you think I'm going to call here? Well, we have a variable called /character movement. We need to initialize that, right? So is there a function that will give us the character movement component? That's right, it's get character movement. Now, this returns a character movement component, which means we need that type if we're going to use this. So we need the header file for that type. Now we can go back to /character and scroll up to the top because we're including character movement component.h here. So we can go ahead and steal this include and paste it at the top of /anim instance here. And now we can take this, which returns a character movement component, and use it to initialize our variable /character movement. So let's do that. So we'll say /character movement equals, and we're assigning the value returned from /character movement. So now we're doing this, which we were doing in Blueprints already, but we deleted those nodes, and now we're doing it here. So now the last thing to do is to update every single frame. And what do we want to update? Well, we want to update our ground speed. So we have our ground speed here. Now, we deleted our other variables and we were only using them here, but ground speed is used in the anim graph. Remember, we go to ground locomotion and our transition rules are using ground speed. So we don't really want to delete it. We're going to keep it here and see what happens. But to get our ground speed, we got the velocity from our character movement component. We're going to do the same thing in C++ now. So in native update animation, we need to get that character movement component, right? So first we're going to check if /character movement. So we only want to access this pointer if it's not null. And if it's not null, we can take slash character movement and access velocity. And we want the magnitude, right? We want the magnitude only in the x and y to be exact. And in blueprints, we used vector length xy, this fancy function that zeroed out the z and gave us the length of the vector with only data in the x and y components. So how do we do that? Well, if we hover over this function, it says what it does, returns the length of the vector's xy components. We knew that. But it also says target is Kismet Math Library. This is a math library, and it exists in C++ as well. We can include it in our project. Now, I leave it as an exercise to you to go to the documentation and search for U Kismet Math Library. That's right, all one word, U Kismet Math Library, and you'll find the include, but I'm just going to show you it here as well. It's Kismet/Kismet Math Library.h. Now, once we've included Kismet Math Library, we can use functions on it. Kismet Math Library is a static library. It contains static functions. Now, we can call a static function on Kismet Math Library by calling U Kismet Math Library, : and we have lots of functions at our disposal. I'm going to put a semicolon there to get rid of our red squiggles. And now if I finish the double colons, here are a ton of math functions. If I just type xy, then here's a function called vSizeXy. And if I get that, notice that it takes a vector as an input. And what do you think it returns? Well, duh, it returns the size of the xy, right? So we're going to pass in a vector. What are we going to pass in? The velocity from slash character movement. Let's highlight it and drag it straight in to the parentheses. And we'll have a semicolon at the end, and we can delete that semicolon. And now we have the size that we need. And this is what we can use to set ground speed. So let's do it. Let's say ground speed equals, and this is what we get. So Kismet Math Library is a class. We see that it starts with a U, and these functions in this class are static, which means there doesn't actually need to be an object of the Kismet Math Library type in existence. These functions don't change any state, any variables on the class. All they do is perform math calculations and return results. So that makes this very useful, and Kismet Math Library has tons of math functions, lots of vector stuff, and other stuff. So really useful to know. So now that we have our ground speed, we're now doing all that stuff we did in blueprints, but in C++ this time. Now we can compile, but before I compile, I'm going to go ahead and hop back into the editor and delete the rest of these, as we're no longer needing any of that stuff here in blueprints. We're doing it all in C++ now, so we can compile. I'm going to close out of the editor first and go ahead and hit Control F5. Now we have a C++ class, and we can go into our blueprints folder, into characters, and open ABP Echo, our animation blueprint. Now we haven't reparented this animation blueprint to set our C++ class as its parent yet. To do that, we click on Class Settings and change the parent class here. So we're going to click the drop down and select our Anim Instance called /Anim Instance. Now when we do that, we see that we've found a member variable with a conflicting name, right? Because we're using ground speed. And notice that it automatically renamed our blueprint variable to ground speed 0. And if we go into our state machine, we see there's an error because it doesn't recognize this ground speed. We have to use our C++ ground speed now. So we can right click and type ground speed. And now we have getters for the renamed blueprint version, and under movement, because we put our C++ variable in the category movement, we can get the C++ version. That's the one we're going to use now. We're going to delete that old one. So we're using it here, and if we go back into ground locomotion, we're also using it here. So we're going to right-click and type ground speed. Get the C++ version now. That's the one we're going to use. And we no longer need the blueprint version. We can go ahead and delete that. And now if we hit compile, we have a successful compile. Now, it'd be nice if we could see our C++ variables here in the My Blueprint panel, and we can. All we need to do is click the gear icon and check Show Inherited Variables. And now if we scroll down and expand variables, we have /anim instance, which has /character, and we have movement, which shows /character movement, and ground speed. So now we don't have to right-click and search for them. We can simply drag them in and get the getter. And notice we don't have a setter for ground speed, as we made it blueprint read only and not blueprint read write. Okay, so now our animation blueprint is parented to our C++ class. And if we go back, we can hit play, but of course we generated Visual Studio project files, and minimal default is in the starter content, so of course it's all reset. So we can go to world settings and change game mode override to BP bird game mode instead, and click play. And we see that our animation blueprint works. Excellent. So before we wrap this up, I'd like to still be able to use this level, but I don't want it to reset to its default every time we generate Visual Studio project files. So for that reason, I'm going to save this as a new level, and that way that won't happen again. So we can go ahead and hit File and click Save Current Level As. And I'm going to stick this new level here in the Maps folder next to /open_world and call this test map. So we'll go ahead and save that, and now we have this test map, which will not get reset the next time we generate Visual Studio project files. And now we can change it and customize it and use it as a sort of testing level. All right, so now we have an animation blueprint driven by C++ data, and we can control that from C++, which is great, but we still don't have the ability to jump. So that's going to be the next thing that we take care of in the next video. I'll see you soon.